So we're talking about dilations, and there are two types. There's reductions and enlargements. All right, so your objectives. You will be able to define a dilation, and you'll be able to perform a dilation with a given center and a scale factor on a figure in the coordinate plane. All right, so let's start with dilations. Dilation is a type of transformation that enlarges or reduces a figure, but the shape stays the same. In other words, a dilation, the two figures are always going to be similar. All right, dilation is described by two different things: a scale factor and the center of dilation. So, like, this would be the original image right here, the pre-image, and the one that says image is the new image. All right, so the scale factor, which we're going to say is K, is the ratio of the length of any side in the image to the length of its corresponding side in the pre-image. It describes how much the figure is enlarged or reduced. Now, we're not going to worry too much about sides because we're not going to be using the distance formula to determine that. We're not using compasses or anything to draw them. But K is the scale factor, and that's the new side over the original side, or in the case of the center of dilation being the point of origin, it would be the new point over the original point. So let's put this into practice a bit. Dilation is a reduction if the scale factor is less than 1. Now, scale factor is always going to be greater than 0, but if it's less than 1, then it's a reduction. So PQR is the original image, P prime, Q prime, R prime is the new image. Okay, it's an enlargement, like I said, if the scale factor is greater than 1. All right, so in this case, this scale factor would be 5 over 2. This scale factor would be 1 over 2. All right, as far as constructing a dilation goes, it's really easy if the center is at the origin. So we construct a triangle on the coordinate plane with A at 2, 4. So let's go ahead and label these. This is A. B is at 4, 4, which is right here. And C is at 4, 1. All right, so the second step is to draw rays from the origin, which is right here on this, through A, B, and C. Okay, O is the center of dilation. All right, so we're going to multiply X and Y by whatever the scale factor is. So if you're given what the scale factor is and you have to create the new figure from that, basically all we have to do is say, okay, well, if I take A, which is at 2, 4, and I multiply both of those by 3. So let's say we have 2, 4, multiply both by 3. Our new point for A prime would be at 6, 12. For B prime, you take 4 and 4 and you multiply both by 3. That would be at 12, 12. And C prime, when you multiply 4 by 3, it's at 12. 1 times 3 is at 3. So your new figure would be over here. This would be A prime, this would be B prime, and this would be C prime. Okay? Now, that would be an enlargement, obviously, because this figure is bigger than this one. If we were to do a reduction, okay, same thing, except instead of multiplying by 3, now we're multiplying by 1/2. All right, so A prime would be at 1, 2. B prime would be at 2, 2. And C prime would be at 2, 1/2. And if you notice, there is 1, 2, so that would be A prime. There's 2, 2, so that would be B prime, which you really can't see. Sorry about that. And C prime is at about 2, 1/2. So that would be a reduction. So obviously reduction, the figure gets smaller. Enlargement, the figure gets bigger. All right, so now let's say that we are going to be doing a dilation where the center is not, or where the center of dilation is not the point of origin. So now it's not going to be as easy as just multiplying each of the vertices by whatever the scale factor is. All right, so basically we're going to draw rays, and I got to change this because it's not -3, -4. The center of dilation would be at, that would be -1, -4. Sorry about that. So we've got our original figure. We draw our rays. And then for a scale factor of 2, basically what we're going to do is we're going to determine, okay, here's our center of dilation. We're going to determine what the slope is. So we went up 4 over 2. So that would be the slope from this to here. And if you've drawn the vertices right, you don't have to worry about doing that for, I shouldn't say the vertices. If you've drawn the rays right, it'll be pretty obvious how the rest of them fall. So for a enlargement of 2, with a scale factor of 2, we just do it again. Up 4 over 2. That would be your other point. This one, you could go up 4, and then this would be over 6. So we would go up 4 over 6. But as you can see, it's pretty obvious where these points are going to fall. Okay, if you look, we go over to the right 6, up 2, over to the right 6, up 2. And then this point is going to fall on the same spot there. And that would be our enlargement. All right, now if we have a scale factor of, say, 1/2, what's going to happen is, let's erase all that. We're going to take and say, all right, well, from here I went up 4 over 2. So if I'm reducing that, I'm only going to go up half of each of these. So I'm going to go up 2 over 1. Okay? And if you do it for all the vertices, that would be your reduction right there. This figure. Let me get rid of this so that you can see it better. So this is the reduction. This is the enlargement. All right. And the thing is, remember, you're moving towards the center of dilation, so having these rays in will really help. All right, and that's about it. We are going to do some problems more closely related to what is going to be on the test, but a couple of things. Don't forget about your notation. If you're already given the two figures and are asked to determine the scale factor, make sure you're moving from the point that doesn't have the prime notation, like this one, to the new figure, which is this one. That'll help you determine if it's an enlargement or reduction. So you've got to remember that prime notation. If you're asked to determine the scale factor, when the center of dilation is at the origin, that's pretty easy. You just do new point over the original point. Remember, if it's less than 1, it's a reduction. If it's greater than 1, it's an enlargement. To determine the scale factor with the center of dilation at a point that is not the origin, you're going to have to use the slope of the two figures to help you out with that, and I'll show you that in class. We'll do a couple of problems like that to make sure that you're